Hi everyone, so today I'm going to be going over all of the different differentiation strategies in year 2, because the year 1 ones are fairly straightforward, but here I have 3 rules that you need to know. With the first rule being chain rule, which you use on composite functions, where like as you can see here, the gx function is inside of the fx function. Product rule is when 2 functions are multiplied together, and quotient rule is when you have 2 functions divided by each other. So to give an example for each of these, for chain rule I could do something like sine 2x squared plus 3, with the sine being the f function and the 2x plus 3 being the gx function. For product rule I could do something like x times e to the x, where x is fx and ex is gx. And for quotient rule I could do something like x to the power of 4 divided by, I don't know, cos x, where x to the power of 4 is fx and cos x equals gx. So I'm going to put timestamps in the description for when I'm covering each of these, but I'm going to start with chain rule. Okay, so I'm going to start off with a nice easy example with chain rule. And this is the formula for it over here, but I tend to not even think about this formula. It is good to be aware of, but I don't really think it's necessary in my opinion. But anyways, to start off with this question, one thing you should always try to test is if you can just differentiate it using year 1 techniques, but you can't with this because of this root here, which I've converted into a half over here. So to start, what I'm going to do is I'm just going to look at this part here, and I can just call it u. Typically I would do all of this in my head, but I'm going to write it down for the purpose of the video. So I would have u to the power of a half, right? So then if I try just differentiating this, it would be a half u to the minus half, right? Because you take 1 off of here, so you get this. Then if I plug in what u was, it would be a half 5x squared plus 1 to the power of minus a half. Then you'd think this would be it, but you haven't actually done anything with the middle part yet, so you have to differentiate this part as well. You differentiate the u. And that's technically what this formula is doing, but it's easy just to think about. So the derivative of 5x plus 1 is just 10x, because the 1 goes to 0 and the 2 times 5 is 10, so you're just left with this. And then you would multiply this with this, so you'd end up with 5x squared plus 1 to the negative a half. And that's just the final answer. It does take some getting used to, but once you figure it out, it becomes a lot easier. So moving on to another example, here I have y equals 1 over 3 plus 2x, right? And this does look like a quotient rule question because it's a function divisible by another function. But you can actually do this using chain rule because of this being a integer here. So you can rewrite this as 3 plus 2x to the power of negative 1. So you can use quotient rule here, but it will just be a bit slower. So this is basically just the same question as before now, where you would just ignore the middle bit here for now, and you would write minus 3 plus 2x to the power of minus 2, and then you multiply this whole thing by the derivative of the middle. So the derivative of the middle part here is just 2, because the 3 is just an integer, it goes to 0, and the 2x, the x is gone, so it's just 2. So then when you multiply these all together, you'd get minus 2, 3 plus 2x to the power of minus 2, and that's it. So now I have a question with an e, and this one is fairly straightforward, but I will go more into how this works a bit later. But for now, we'll just do this question. So again, if I imagine this part as just u, or it can be anything you want, but I'm going with u, this would just be e to the u, right? So then if you differentiate this e to the u in terms of u, that's just going to equal the same thing, e to the u, right? Then if we go back to what we did before, we haven't actually done anything with the u yet, right? So then we have to differentiate the u part, which is the cos x, and if you differentiate cos x, that becomes minus sine x, right? Then if you just multiply these parts together, you end up with minus sine x e to the u, right? But e to the u is e to the cos x, so that's just equal to minus sine x e to the cos x. All you do with ex is you just differentiate the power of it and then add it to the front. That's literally it. So moving on to another chain rule question. So this one does look a bit more confusing, but it's actually not too bad. So again, if I go with my u strategy, if I let this equal u, then it would just be y equals ln u, and if you differentiate that, it's just going to be 1 over u, right? But we haven't actually done anything with u yet, so then we differentiate it, and sine x differentiates to cos x. So then you multiply this by this, so it would be cos x over u, so cos x over sine x, which is equal to cot x. So for our penultimate question, I'm going to do this without using the u sub, so it becomes easier for you to do it in your head basically. So if I just start this off by doing 5 sine x plus cos x, you can imagine the middle part here is u if you want, but that's basically what I had before, right? Then you have to differentiate the middle part, which is just going to be cos x x minus sine x. So you'd end up with 5 cos x minus sine x multiplied by sine x plus cos x to the power of 4. And that's it. Okay, so for a final example, I'm going to do this question. So if I just get right into it, I'm going to do dy dx. I have been forgetting to write this, but make sure you do, it's very important. It's going to start with minus sine and then this, because that's what the cos differentiates to. But then you have to multiply it by the inside bracket here. So using year 1 techniques, you know that the differentiation of this is just 2e to the 2x. So then that's just your final answer. Minus 2e to the 2x sine e to the 2x plus 3. So next I'm going to be moving on to products rule. So products rule is like the most fun thing ever, but it is kind of annoying sometimes because you do need to use chain rule as well as products rule in some of these questions. But the way you identify if it's products rule is if it's just two functions multiplied, which you can see they are here. So the first thing I'm going to do is I'm going to split this up into two functions. So I'm going to let u equal x squared and I'm going to let v equal 3x minus 1 to the power of a half. Then I'm going to differentiate both of these due to this formula right here. I also don't use this formula, but you can if you want to. So I'm going to call this u dash, which is going to be 2x, and v dash is going to equal 3 over 2, 3x minus 1 to the power of negative half, and that's using chain rule. So just to simplify that formula a bit, is basically just saying uv dash plus vu dash. These can be in any order as well, which is nice. All you have to do is just multiply these together and multiply these together, and then just add them together. So if I do uv dash first, that's going to be 3 over 2 x squared 3x minus 1 to the negative half, and then I'm going to add the u dash and v, so add 2x 3x minus 1 to the power of a half, and that's literally it. So it's very nice and straightforward, but keep in mind sometimes questions will ask you to simplify it more, but for this this form is fine. Okay, so for the next question, I'm going to split this up into sine 2x and cos 3x. So u is going to equal sine 2x, v is going to equal cos 3x, and then we have to differentiate both of these. So we're going to end up with 2 cos 2x. Hopefully you all know how to differentiate sine 2x and cos 3x. It is just chain rule, but from this hopefully you can see how it works. So then v dash is going to be minus 3 sine 3x. Then we're just going to multiply this and this, which makes a nice multiplication sign. So we're going to end up with minus 3 sine 3x times by sine 2x. We add brackets in to make it look a bit nicer. And then going to add, I'll put it here actually, 2 cos 2x cos 3x, and this is just the answer. So moving on to the next one. Okay, so with this example I'm going to show off a quicker method of doing this, where typically what I would do is cover parts up with my thumb, but I can't really showcase that right now, so just imagine that that's what I'm doing. So first of all, imagine I'm covering up sine x here, so that's the part you don't want to differentiate. So then what you do is just differentiate the e to the x and then add the sine x part onto it. So that's basically just going to be e to the x sine x. Then now we're going to cover up the e to the x part, so that's just going to be differentiating the sine x part, and then that's going to be e to the x cos x. And always remember to add these instead of multiplying, because that's how products rule works. But then you can just simplify this to e to the x sine x plus cos x, and that's just it. So now moving on to the next question. This one is a bit tricky to do in your head because of the chain rule parts in both of these. So it may be easier to write u and v here, but that is also kind of slow, so it's up to you, but I'm going to just try solving this partially in my head. So first of all, this is u, so we're going to cover that up for now, and we're just going to differentiate the ln 3x, so that's going to be 1 over 3x times by 3 from chain rule. So the 3's cancel out, so you're just left with 1 over x times by 2 sine x minus 3 cos x. Then you're going to cover up the ln 3x this time, so we're just going to differentiate this part and then add this part on. So differentiating this is going to be 2 cos x plus 3 sine x, and you can leave it like this, I think, unless it asks you to simplify it. Okay, so moving on to part B. This one's also quite nice because of the x to the power of 4 here is just year 1 differentiation. So using the trick from before, I'm going to cover this up for now. So it was just going to be 4x cubed, because you just differentiate this and then you add on this, e to the 7x minus 3 plus, now we're going to cover up this, so x to the power of 4 and then differentiate this using chain rule. So 7e 7x minus 3, because differentiation of this is just 7, so that's why it's at 7 there. Then you can simplify this to x to the power of 3 e to the 7x minus 3 4x plus 7. And there we go. That's all of the products rule questions I'm going to do, so I'm moving on to quotient rule. Okay, so next up I have this question here, and you may be able to notice that you can actually do this using chain rule and products rule, but I'm going to be showing off quotient rule now. Like, I could rewrite this as y equals x 2x plus 5 to the power of minus 1, and then you can just use chain rule on this. But as you can see in this corner here, I have the quotient rule formula, which does look a bit confusing to remember, but there is a simpler way that I like to remember it. Well, this is vu minus uv over v squared, and there are dashes here and here. So I remember it like this because it makes like the vuv sound, like vuv, and the dashes always go at the ends of like these two blocks, and it's always v squared at the bottom. I tend to just remember that, but if you don't, then one way you could remember it is by checking that these are the same, like 1 and 1 here, and 2 at the bottom. So it's 2 at the top, 2 at the bottom. But using this formula on this, u is going to be x, v is going to be 2x plus 5. So u dash is going to equal 1 and v dash is going to equal 2. So then plugging it into this formula here, we're going to have dy dx equals 2x plus 5 multiplied by 1 minus x and 2 all over 2x plus 5 squared. So then this will simplify to 5 over 4x squared plus 10x plus 25. And I'm pretty sure that's it. So yeah, you can keep this as 2x plus 5 if you want, but I just expanded it. Moving on to the next question. Okay, so this one is a bit more challenging, but hopefully it should still be understandable. So first of all, I'm going to put it into my u's and v's. So u is always going to be the numerator, so in this case it's ln x, and v is going to be tan x, because that's the denominator. Then we differentiate both of these. So u dash is going to be 1 over x, and v dash is going to be sec squared x. If you don't know this, then it is in the formula book, so you can just check that if you're stuck. Then we're going to put it into the formula. So tan x 1 over x minus ln x sec squared x, and that's going to be all over v squared, so that would be tan squared x. And there's not much simplifying you could do here, so I think I'm just going to multiply the top and bottom by x just to simplify that a bit. So you're going to end up with tan x minus x ln x sec squared x all over x tan squared x, and that's it. So on to the next question. So with this next question, the reason why I chose this one is to show you all that u can be equal to more than one value. So like in this instance, it would be u equals e to the minus 2x plus e to the 2x, and v is going to equal ln x. Then we're going to differentiate both of these. So u dash is going to be minus 2e to the minus 2x plus 2e to the 2x, and v dash is going to be 1 over x. Then plugging this into the formula, we're going to get ln x minus 2e to the minus 2x plus 2e to the 2x minus e to the minus 2x plus e to the 2x multiplied by 1 to the x, and this is going to be all over ln x squared. Then we can simplify this by multiplying by x over x. I'm not going to write that all down, but hopefully that makes sense, just so you can cancel out this x here. So the final simplified solution is going to be e to the minus 2x x ln x 2e to the 4x minus 1, and then minus 1 minus e to the 4x. That's all going to be over x ln x squared. Okay, so last question with quotient rule. I'm just going to start off by doing my u's and v's. So u equals e to the tan x, and v is going to equal cos x. So then u dash is going to equal sec squared x e to the tan x using our chain rule from earlier, and then v dash is going to equal negative sine x. So I'm going to start by plugging this all into the formula. So we're going to end up with cos x sec squared x e to the tan x, and already something that you may notice is that sec squared x is just equal to 1 over cos squared x. So all this is here is just cos times cos squared x, so you end up with 1 over cos x, which is just sec x. So you can simplify this now if you want to sec x e to the tan x. Then we're going to subtract uv dash, so that's going to be e to the tan x and minus sine x, and this is going to be all over cos squared x. Then we can pull out our e to the tan x, so we're going to end up with sec x plus sine x all over cos squared x, which then simplifies to e to the tan x sec cubed x plus sec x tan x. That's from doing sine x over cos squared x. I'm going to leave it like this, but you can simplify this more by pulling out a sec x if you want. But yeah, that's the last quotient rule question, so I'm going to move on to parametric differentiation. Okay, so parametric differentiation is probably one of the easiest things on here because there is this formula here, but it's not really necessary to remember it like that in my opinion. This is just chain rule, but all you have to do is differentiate both x and y in terms of t and then put y over x basically. So I'm going to start by doing y here, so dy dt is just 2t because of like year 1 differentiation strategies, and then dx by dt is just going to equal 3t squared plus 1. And then all I have to do is put dy over dt over dx over dt. So dy over dx equals 2t over 3t squared plus 1. And that's it. So let me move on to an actual question now. So I've got my next question here. I'm just going to start by differentiating the x part in terms of t. So dx by dt equals 4 sine t cos t using chain rule. And then dy by dt equals negative 2 cos x squared x. And that is in the formula book. So now if I just put the dy dt part over the dx dt part, that's dy dx, and it's going to equal negative 2 cosec squared t all over 4 sine t cos t. Then you can just simplify this by bringing out the minus 2 over 4, so minus a half. Then cosec squared t goes to 1 over sine squared t, so that's going to be 1 over sine cubed t, and then cos t. And then you can simplify this a bit more by making it minus a half cosec cubed t sec t. And there we go. Okay, so moving on to this next question, I'm going to start by doing the same thing again. dx dt is going to equal minus 4 sec 2t tan 2t. That's also in the formula book. Then my dy by dt is the same one as the last question actually, so it's just going to equal minus 2 cosec squared t. Then we just put dy over dt by dx over dt, so dy by dx equals minus 2 cosec squared t over minus 4 sec 2t tan 2t. Then you can probably just make this into a half of the same thing, and I think this is probably about as simple as you can make it. You can try and simplify it more, but I think this is fine for an exam. So these questions aren't actually too bad, like they wouldn't be much harder than this in an exam, so I'm going to move on to implicit differentiation now. Okay, so implicit differentiation is actually really interesting because it's something that you have probably already been doing, but you might not have been aware of that. So say for example I had like y equals 2x, what you would do is you would write dy dx equals 2, right? So then what you've actually done is you've differentiated both sides. So the differentiation of y in terms of x is dy dx. So that's what this topic really explores. So if I just showcase that with this example here, you'll notice that this is not just in terms of y, right? It's in terms of x and y. So one thing you could do is try and rearrange this for y and then differentiate normally, but something a lot easier to do would just be to differentiate implicitly. So what you can do is just start off by doing 3x squared plus 1. Then we get to the y part and we just differentiate this normally, but then because this is y and it's in terms of x, what you have to do is you have to add a dy dx to the end of this here. So just a tip to remember, if you're ever differentiating y, always add a dy dx onto the end just to like fix it basically. The real reason this works is because of chain rule, as you can probably see by these results here. So then the same with this part here, because it's 3y, we're just going to write plus 3 dy dx because we differentiated the y here. And then we get to the other side. This goes to 0 because you always have to remember to differentiate both sides when you're differentiating implicitly. So the 6 goes to 0 because it's constant. So now the question asks you to put it in terms of dy dx, right? But this is just a lot of random stuff we have right now. So what I'm going to do is keep all of the x terms on one side and put the dy dx terms onto the other side like this, and then you can just factor out a dy dx, and then we can just divide by this part and we'll get it as just dy dx, right? So dy dx equals 3x squared plus 1 divided by minus 3y squared minus 3. And then you can factor out this minus here, but I'm just going to keep it like this. So yeah, let me move on to another example. Okay, so I've chosen this example because it showcases a lot of products rule, and if you can do this one, you can basically do all of them. So I'm going to start off by doing the left hand side. So ex to the y, if I cover up the y first, then that's just exy again. And then if I cover up the e to the x this time, then it's going to be plus e to the x dy dx. because we differentiated the y. And then on the other side, we're going to cover up the e to the y first. So x just goes to 1. So this is just e to the y. And then we cover up the x, so plus x. And then e to the y differentiates to e to the y dy dx, because we're differentiating y this time. So now all we have to do is just rearrange for dy dx. So I'm going to bring all the other terms to the left hand side. So e to the xy minus e to the y equals x e to the y dy dx minus e to the x dy dx. So then exy minus e to the y equals dy dx x e to the y minus e to the x, and then we can just divide by this, and that's the answer. So dy dx equals e to the xy minus e to the y all over x e to the y minus e to the x. So yeah, that's it. I'm just going to do one more trigonometry question now. Okay, so this is a fairly simple question, so I'm just going to get right into it. So sine x goes to cos x, and then minus cos y goes to negative sine y, and then you always have to remember to add the dy dx, just like that. And then the half is going to go to 0, because again, that is a constant, and we're differentiating on both sides. So what I'm going to do is just add the sine y to the other side. So cos x equals dy dx sine y. And then all I have to do is divide by sine y. So dy dx equals cos x over sine y. And keep in mind that you can't simplify this anymore because the x and the y are different, so you can't use any identities there. So yeah, that is all of differentiation. So let me know if you have any questions in the comments, but thanks for watching, bye!